Hello serverless people, welcome to another video about the AWS Solutions Architect Associate exam. And this video will explain the EBS and EFS services. Remember, these are one of the core services that I'm gonna be asked on the exam. So stay tuned and we're gonna go through all the features and concepts that you need to know. As always, in the second part of the video, I will also answer some AWS questions that I found on the exam. I think it's a very useful exercise for you so you understand how the questions are made, how to identify the right answer as well. So let's get started. First of all, what is EBS, which stands for Elastic Block Store? EBS is a block storage designed for EC2 instances. You can say it's production ready, meaning that it's designed for mission critical workloads. It's high available. It's automatically replicated within a single availability zone. So remember this. Automatically replicated within a single availability zone, and it's scalable. You can increase capacity and change volume type with no downtime. You can do that directly from the console or from infrastructure as a code systems. The main feature is we have to remember that EBS volumes will always be in the same availability zone as the EC2 instance. You can resize the volume on the fly, meaning you can resize the EBS. There is no need to stop the instance. You can actually, the only thing you need to do is to extend the file system so you can see the resized volume. And you can also change the volume types, meaning that you can change the volume types again on the fly. There is no need to stop the instance. So before we continue, let's refresh our minds with the concept of IOPS and throughput. So IOPS measures the number of reads and write operation per second. The use case for this is quick transactions, low latency app and transaction workloads. When basically you need like read and write very quickly. Usually you will choose between IOPS SSD, which is IO1, IO2. And we're gonna go through the SSD volumes just in a minute. Then we have the throughput. The throughput measures the number of bits read or written per second, so megabyte per second. Use case is large datasets, think about databases, large I/O size, a complex query. This is the best use case for this is for dealing with a large dataset. You can choose throughput optimized HDD, and we're gonna see also the types of HDD available in a second as well. So let's go through the SSD volumes and family that you need to know for the exam. Remember that you don't need to know all the stats and data about it, just a few key concepts. So the general purpose SSD, which is called also GP2, is suitable for having it as a boot disk for your EC2 instance and also for general case application. It supports up to 16,000 IOPS per volume, and it has up to 90.99% of durability. So this is basically the general use case, the general option when you want to spin up an EC2 instance. Then we have the same family of the general purpose SSD, but this is just a new, volume. It's just a new, volume developed by AWS in the last years, and it's called GP3. It has very similar characteristic to the GP2. Remember that in the exam, it's very unlikely you're gonna have to choose between GP2 and GP3. Usually is between like SSD and HDD because the two volumes are really like similar. So we said GP3 is suitable for high performance apps. So it has this baseline performance of 3000 I/O per second, and then we have 125 megabyte per second at any volume size, and durability is the same. Then we have the so-called provision IOPS SSD, and the acronym is IO1, and this is useful for OLTP and latency sensitive apps. So when in the exam they ask you about a very high performance, usually they tell you more than 60,000, 20,000 IOPS per volume, which is the maximum for the general purpose SSD. That's when you want to go with the provision SSD. This is for high performance apps, and we have again here two families which are kind of similar. So remember that is IO1 and IO2. And as I said, it's very unlikely you have to choose between these two. Usually it's between, GP2 and IO1 or GP3 and IO2. So this is for the SSD volumes. Then we go on the HDD volumes, which of course are throughput optimized. So this is suitable for big data, data warehouse use cases, and ETL. The max throughput is 500 megabyte per second. It cannot be used as boot volume, so remember this. You cannot use an HDD as boot volume, and it has up to 99.9% durability. Then we have the other one, the cold HDD. Remember, this is the cheapest option, so every time you see like on the exam cheapest option, think about cold HDD. It cannot be used as a boot volume again, and is suitable for less frequently accessed data. And max throughput is 250 megabyte per second. So usually when they ask you the lowest, the cheapest option, lowest cost, and for less frequently accessed data, this is the way to go, like cold HDD. So let's move on the snapshots concept now. So snapshots are for the EBS volume, and you can think about snapshots as really like a photograph of the virtual disk of volume. They are stored on S3 and it's like a point-in-time copy of the volume. And remember these snapshots are incremental, meaning that the first snapshot will take a bit more time because the first one it has to do all the creation procedure. But then when you're gonna do the other snapshots, the snapshot is gonna be incremental, meaning all the data that has been changed since the last snapshot are moved to S3, and this saves space and time. You can have consistent snapshots, which basically saves only the data that has been written in the volume and excludes any data cache in your application or operating system. And to do that, it's recommended to stop the instance. Remember that you can do a snapshot when an instance is running, but in order to have like a consistent snapshot, meaning you want to have in the snapshot only the data that has been written in the volume, you may want to stop the instance. You can also encrypt the snapshot. So if the EBS volume is encrypted, which is usually is not encrypted by default, you can check the encryption option when you create a volume. But if the EBS volume is encrypted, also the snapshot will be encrypted. Remember that you can also share the snapshots, so you can share the snapshot only in the same region they've been created. And if you need to share the snapshot in other region, you need to copy them to the destination region first. So I remember on the exam, I've seen some questions saying, you are a company, you have snapshot in, region EU West 1, you want to copy those snapshot in another region, or you want to move the snapshot to another region. How you want to do that? The answer is you need to copy them to the destination region first, and then from there you can do you can create an EC2 instance, for example. So remember this for the exam, like how to share snapshots, you need to copy on the destination region first. Alright, so that was all for the snapshots. And let's see actually how the encryption works for EBS volumes. As we said, EBS volumes are not encrypted by default. Once you turn on the encryption, the volume basically will have the data at rest encrypted. All the data between the instance and the volume is encrypted. All the snapshots, as we said, are encrypted. And all the volumes created from the snapshots are encrypted as well. Encryption and decryption, here there is like a typo, just notice that, are handled transparently by AWS, meaning that you don't need to do anything. It's all handled under the hood by AWS for you. It has a minimal impact on performance or latency, so don't worry about that. And if you have like an encrypted volume and you want to encrypt it, you can copy the encrypted volume, and while you are creating the new volume from the copy, you can select the encryption. It's also possible to encrypt the root device upon creation. So very important because you're going to be asked this on the exam, how to encrypt an unencrypted volume. So you need to memorize this process. In order to encrypt an unencrypted volume, you need to do these 4 steps. So create a snapshot of the unencrypted volume. So you do a snapshot of the unencrypted volume, then you create a copy of the snapshot and check for the encryption option. Once you have encrypted the volume and the snapshot, you create an MEI from the encrypted snapshot, and then you can use the MEI to launch the new encrypted instances. Remember this procedure. Try even, to do it on the AWS console, because you're going to have scenario-based questions asking you, your security team asks you to have all the EC2 volume encrypted. How do you do that? Or how do you create an encrypted volume from an unencrypted one? So let's say it again. You first create a snapshot of the unencrypted volume. Then you create a copy of the snapshot and check the encryption option. You create an MEI from the encrypted snapshot, and then you launch the MEI from the encrypted snapshot that you created on step 3. And that's the only procedure you need to know for this question. Okay, now let's move on the EFS cheat sheet, which stands for Elastic File System. So the Elastic File System service support the Network File System version 4 protocol, also called NFS version 4. You only pay for the storage you use. You don't need to pre-allocate the space. So it's not like when you create a volume with EBS that you have to select the gigabyte that you want to use. Here you only pay for the storage that you use, and you don't need to select it when you create the EFS. It's going to be handled by AWS. It can scale up to petabytes, and it supports thousands of current NFS connections. And again, this is all scaled by AWS for you. Data is stored across multiple availability zones within a region. So it's not like the EBS volume, which are within the same availability zone, but EFS is stored across multiple availability zones. And it has read after write consistency. If you don't remember what is read after write, it's basically the file is going to be available as soon as being written on the disk. There is also I made a video about it when I explained this concept on the S3, because S3 also has read after write consistency. So I'm gonna put the video here on the top right. So let's see the different EFS that we have for AWS. You need to remember this two classes. So basically we have File System X for Windows, and this is basically a fully managed native Microsoft Windows file system. It is designed for Windows and Windows-only applications. Supports, Active Directory users, ACL groups, and all the namespace and replication data for Windows. So every time you see on the exam the Windows keyword, think about FSX for Windows. This is really the only thing you need to remember. When you see file system for Windows, go with FSX for Windows. That's the only thing you need to remember. On the other hand, EFS is a managed NAS system for EC2 instances based on, as we said, NFS version 4. And this is the network file sharing protocol native to Unix and Linux. And then we have a third option, which is the FSX for Lustre. When you need high-speed capacity distributed storage needed for, HPC, high-performance compute applications such as financial modeling, this kind of stuff, you need to select the FSX for Lustre, which is really file system for this only system. FSX for Lustre can store the data on S3, but as I said, the only thing you need to remember for the exam is when you see high-performance compute application, financial modeling, and you say you see open source Lustre system, go with FSX for Lustre. That's the only thing you need to remember. So remember, FSX for Windows, EFS, and FSX for Lustre. That's basically the keywords you need to remember for the exam. Now let's go on the next concept. What is an AMI? An AMI stands for Amazon Machine Image, which basically provides the information required to launch an instance. It's basically a blueprint for an EC2 instance, really. It's really what it is. It's a blueprint for an EC2 instance. An MEI can be backed by an ABS volume or an instance store. And now we need to see the differences, and you also need to remember these differences for the exam. So when the AMI is backed by an ABS volume, it means that the root device is an ABS volume created from a snapshot. It can be stopped and you won't lose data. It can also be rebooted and you not lose data. But if the instance is terminated, the EBS volume will be deleted by default. This is an option on AWS. You can, though, tell AWS to not delete the volume. So when you create the instance, you can tell on termination, please don't delete the volume by default. On the other hand, when you create an EC2 from an MEI backed by an instance store, Basically, the instance store is a template stored in S3. It's also called ephemeral state, because basically you cannot stop the instance, otherwise you will lose all your data. You can reboot the instance though without losing data. So remember, you can't stop the data with an instance store, otherwise you can't stop an instance with an instance store, otherwise you will lose your data. Whereas with EBS, you can stop the instance and you won't lose data. And also, you can reboot the instance without losing data, both with instance store and EBS. So there will be questions asking you the difference, so they're gonna kind of play with these differences. So you need to be very clear about these two concepts. Now let's see a service from AWS called AWS Backup. There might be questions about what is AWS Backup, or like a use case where one of the answers is AWS Backup. You need to remember basically three basic concepts about it and the benefits of using this service. So with AWS Backup, you have basically consolidation, meaning that you can, use this service to backup services such as EC2, EBS, EFS, FSX, and AWS Storage Gateway. So all these services can be used with AWS Backup. And you can also use this service along with the AWS Organization service to back up your different services across multiple AWS accounts. So let's say you have different, AWS accounts for develop, production, and QA, for example. You can use the AWS backup in all these accounts and distribute the backup in these accounts as well. So the benefits of using this service is that your backups are centralized on your AWS account. Is better for compliance because you can basically apply backup policies, ensure that your backups are encrypted, and you can also audit them once they are completed. So really the big benefit is that they are centralized and you can apply backup policies for compliance. Last quick concept, and then we're gonna move to the exam questions, is the EC2 hibernation. When you create like an EC2 instance, usually you can stop the instance or you can terminate the instance, but you can also hibernate the instance, meaning that the Amazon EBS volume is restored to its previous state, meaning that the instance, first of all, will maintain its instance ID, and when you resume the instance from hibernation, the EBS volume is restored to its previous state, the RAM content are reloaded, and the processes that were running on the instance are resumed. So the boot up is much faster because it doesn't need to boot up the system. It's all stored in the volume. And remember just this data that an instance cannot be hibernated for more than 60 days. And that's basically what you need to know about EC2 hibernation. All right, let's see some exam questions or EBS and EFS. So let's get started. First question. A company is designing a high scalable system to track records. The records must be available immediately for download for 3 months and then must be deleted. What is the best approach for this use case? All right. So store the files in Amazon EBS and create a lifecycle policy to remove the files after 3 months. Store the files in Amazon Glacier and create a life policy to remove the files after 3 months. Store the files in Amazon S3, same thing. Store the files in Amazon EFS and create a lifecycle policy to remove the files after 3 months. So like some of the answers can be correct, like you can do that using EBS or EFS, but of course it's not the best case for these technologies. So the right answer is to save the images on S3, and then the lifecycle policy is embedded with S3, and it's much easier to use it. So the correct answer is the letter C. Question number 2. A team is building an app that must save JSON data in a high available data store. The latency of the data the latency of the data must remain consistent despite very high application traffic. Which service will help for this use case? All right. So Amazon EFS could be. Amazon Redshift, no, because it is like a data warehouse technology. DynamoDB, yeah, I like this answer because it's the perfect match for this use case. AWS CloudFormation is just an infrastructure as a code service, so it's not the answer for sure. So for this use case, I will go with DynamoDB. This is the answer because it's the latency of the data is basically contains the same, even if the traffic is high. It is embedded with DynamoDB and it's handled by AWS. So this is the best answer for the question. You need to store images that are uploaded by users using a mobile application. It is also required that security measures are in place to avoid data loss. Alright. What steps should be taken for protection against accidental user action? Store data in an EBS volume and create snapshots once a week. Okay. Store data in S3 and enable versioning. That's a good answer, really. Store data on Amazon EFS, very generic. Store data in an in-situ instance storage. This doesn't make sense. So for this case, since we need to require that like some mechanism to avoid data loss, the use of S3 packet and enable versioning is the best option, because with versioning you can basically have different versioning of the file, and you can also have, if you delete accidentally a file, you can have the deleted object saved for you when you enable versioning. If you want to know more about this, I also made a video. I'm going to put in the description. So this is the correct answer, answer B. Let's go to the next one. You are hired as a solutions architect from a company that wants to host a DB, so a database on EC2 instance. The requirement is that it should support 32,000 IOPS, which Amazon EBS volume will meet this requirement. All right. So here is a very high volume, and I don't know if you remember that, but the general purpose SSD supports up to 16,000. So here the only available option for this workload is EBS provision IOPS SSD. As I said, you need to remember just key data for the different EBS options, and the max IOPS per second data is one of the data you need to remember. So in this case, we know the provision SSD is the answer. Okay, let's move to the next one. A company has an application deployed in a local data center. Its file storage is built on a Microsoft Windows file server. Okay, Microsoft Windows file server. The application and file server needs to be migrated to AWS. The application code should continue working to access the file systems. Which method should we use? Okay, so very important, Microsoft Windows file server. Create a Windows file server for Amazon Workspace. No. Configure a high-performance Windows file system in Amazon EFS. Remember that Amazon EFS supports only Linux or Unix system. Create a Windows file server using FSX. Yes, that's the answer I was looking for. So remember, as I told you, when you see Microsoft Windows file server, FSX is the option. And then the last one was like configure the storage using Amazon Workdocs. No. So let us see. Windows file server using FSX is the right answer. So next one. You are developing a high-performance computing HPC application which needs a high-performance and low-latency file system. You need to configure the file system at lower cost. Which service would you use? Okay, here key keywords are HPC application, high performance and low latency. Create a raster file using Amazon FSX. I like this option really because that's what I was looking for. So I'm going to highlight this one for now. Launch a high performance raster file in Amazon EBS. Amazon EBS doesn't support raster file. Create a high speed volume cluster in EC2 placement group. This doesn't make sense. Launch the raster file from AWS Marketplace. No, doesn't make sense at all. So the answer is A. Create a raster file using Amazon FSX. That's the right answer. Okay, last question. A company is using EBS snapshots to back their EBS volumes. The CTO asks you to make these snapshots available in other regions. How can this be done? Okay, so here, as I said, I don't know if you remember from like 10 minutes ago, we need to remember the procedure in order to copy snapshot to another region. Remember, the snapshot are available only in the region they've been created. So in order to move snapshots, we need to basically copy the snapshot to the destination region. So answer A, create a snapshot in another region. No, this is not true. Copy the EBS snapshot to an EC2 instance in another region. This is not possible at all. Create a snapshot and copy it into another region. Yes, that's the answer I was looking for. Copy the snapshot to S3 and replicate the bucket in no, this is really doesn't make sense. So create a snapshot and copy it in another region. As I said, if you check my cheat sheet in here, you need to memorize this option. So how to share snapshot, you can share all in the same region that were created. To share to other regions, you need to copy them to the destination region first, which is basically what I've done here. Create a snapshot and copy it into another region. Alright folks, this was all for this video on EBS and EFS. I hope it was useful. Remember the cheat sheets that I create are available on my Twitter account. Also remember to subscribe to the channel so I can make other videos. This really helps me to, support the channel. And thanks again for watching. See you on the next one.